Okay, good day. My name is Jeremy. Today I'll be working on how to design a portal frame using robot structural analysis, and this is a typical portal frame design here. I have here with me braced there, and we have our struct tie down walls, and our struct is an SHS. You have our UB, and we also have our universal beam here. Our universal beam is used for the rafter, while our universal beam is also used for the column. We have our equal angle used as truss, acting in tension, which serve as bracing for this steel structure here. So I'll create something similar to this, but not exactly like this. I'll go down to my robot structural analysis and launch what we have here. So this is my portal structure interface load. We have this is called the shell, the building, the concrete element, and you can also create a predefined portal frame structure earlier on. But for this class, we'll click on new, then you go down to this shell. Can you see frame 3D? And this is very easy, but for this class we go for shell. So the shell will load. Then you have this beautiful interface for our robot structural analysis. So you come down to your job preference, which is on tools. You come down to your job preference, you make sure your unit is set, and dimension is on meter, section dimension is on millimeter, section properties. You come down to your forces, you confirm, then you go down to your orders, unit edition, you confirm, materials. So we are not concerned here, we are using the British materials here, X25275. Then you go to your database, you click on this plus button on the database, then you check for your steel. We are using the UK section. Then you come down to your bolts, check anchor bolts, reinforcing bar, wire fabrics. So you come down to your loads. Our combination is BS8110. We might decide to use 0 code also, but we might decide to use BS5950 if I want. And you come downwards and you come to your structural analysis to check okay, parameters. You can leave others like this. You can take the DCLC and algorithm for bar releases, and if I'm using a rigid links in this, maybe I want to model my base plates and check myself for deflection and other stuff. Okay, so I'll click on OK. You might save current parameter as default. You click on OK. So unlike other structure whereby you create your ASICs and it's more easier, but for robots you come here to define your ASICs. Can you see ASICs definition? You click on it. So if I like I said earlier on, we are making something very similar to this. So let's assume this is a 25 meter span portal frame here. So I'll go back to my robot. Then if you should look at the coordinates from here, look at this is front. You can click on this home button to have you on that perspective view, on that 3D view. This home button, just click on it once. So we know that our y is like this, while the x is like this. So if I'm coming down by x, I'll have 0, my first point. Then now my second point will be 6.25. I'll click on add. I want another point of 9.375. I'll click on add. I want another point of, let's say, 12.50. I'll click on add. Another one of 18.75. I'll click on add, and I need another of 21 point, maybe 88 or so. I'll click on add, and that of 25. So from 0, which is our first point, to 25, so the center point of our portal frame is this 12.5. you just click on 4, you click on single out for me to be able to recognize it. Then our y, I want our portal frame to be equally spaced, so my y will go from 0 to 30. Just hit on 0. The number of repetition should be 6 times 5 is 30. Then distance of 5 then click on add. So you have 0, 5. So you should notice the X is labeled on 1, 2, 3. So I want my Y to be labeled on alphabet, so ABC, so it will reach G. So my Z, I want my first point on 0, my next point on 0.6 also, then I want another point of 6, then this should be my rafter height, 6.6, add, then I'll click on apply, then I'll hit on close. You might give this another, let's say define, and you call it anything you want if you want, but I'll do it like this. I'll click on apply, I'll click on close. So now this is where I will create my footer frame, and this is where to make your section, your bars. You come to bars, so you have it predefined. You have the simple bar, and if you want to choose your section, you click on this section. So after hitting on this section, you wait a little bit, it will pop up. Then you come here, you make sure this is on X275. If it is not, you go back to your job preference to set it. Then still, okay, you can change your gamma angle from here. We'll later understand what the gamma angle means. So firstly, I only need a U-beam. You come here to click here, and you go to your U-beam. So I'll choose my primary section, and if it fails, then I will instruct robot to increase it. So my primary section, let's try a 306 by 165 by 40 UB. Let me see, do we have that? Okay, 305 by 165. So I want to give it a color. You can give it any color you want, but I would like a purple color. I'll click on add, I'll click on yes, then I'll click on close. If you should notice, then you can come here a 305 by 165, because I have it defined before my 16. That is why. If not, you should have seen it popping up itself. Then you just click inside this box here. You can define the coordinates if you know the coordinates, or you know how to work pretty well with the coordinates. So I'll come here from this point 0 here, I'll bring it downwards to 3. As you can see from this, it is perfectly aligned well. Okay, so this section I created, I want to change it. I don't want to use this should be for my rafter. I want to make another section for my column. So this will lead us to how we can change a previously defined section. So I want to make our column a 406 by 160 40, 406 by 140 by 46. So you come back here, choose your UB again, then I'll search for, okay, here you come here, I'll search for a 406 by 140 by 39. You give it a color, any color you want. You click on add. I have it defined before. If not, it will not have pop up this. You just click on yes, it will come up here. So you click on close, then you click on close here. You pick the previously defined bar. If it's just this one only, you can just click on it and come down here to the section here to choose the 406 by 139 by 46 earlier created. But if you want to change all the previously 350, then 306, you can just right click like this one now and do what is known as select by cross section. Then I'll change to 406 by 140 by 26, and it has changed. Then you can view it by the section shape, which is more bigger, as you can see. So now you should notice you are assigning a color and it is not coming up. You just right click on your mouse and you go down to your view. Where's my view here? Okay, display. You go down to your display, you come to your bars, then you can choose on your section shape by color, then you click on apply. So you click on OK. So if you should notice this here, it will be like the legend for each bar created. So when looking at the bar, you will know which member it is. So now let's create our rafters. So my rafter will come like this. So I'm using this 305. So I want to come down from here to the tip, then from here downwards you hit on drag to move from the last point, then you hit on escape once, then close. So now for this I want to change it, I want to align it the other way. You click on it. After clicking, you come down here to your gamma angle, then you change it to 90. You can rotate, but you should be careful on how you rotate because it has a major and minor axis, whereby it will act differently on each part you rotate to. So now what we are going to add next is an hunch or a bracket here, which is 20% span of this guy here, this rafter. So how do we do that? We'll come down to our geometry, we'll come to additional attributes, we'll come back to our bracket, and we'll make a new bracket. We click on new, and okay, we'll call it 0.20, and we want to make this bracket. It is usually made from the previously defined section, and okay, so we want it downwards. You click on add, you click on close. So this is bracket 1. You can rename it if you want. Let's call it okay, I'll call it hunch. If just have hunch like that, I'll call something closer to that. Okay, close. This is it here. Then I'll delete this, and then this again. So now this hunch, you have to be careful. You pick on this bar, or you can define this hunch directly. You click on apply. So can you see? That is it. Then you click on this bar also, which is bar 5. Apply. No, I don't want it here. So how do we do this? You just come to your delete, and you click on the bar. It will go off. Okay. No. No. Okay, let me go back there again. Geometry, additional attributes, bracket, hunch. Okay, so just click on this hunch one, so you can just move down closer to where you want to put it. So now this is our hunch. So how we're going to create now is moving this frame backwards. Click on close. We are through with this. Then you can highlight this guy here. After highlight, you come down here. Look at this arrow here. It is the edit button. Look at this. Is move copy. We have the rotation, horizontal mirror, vertical mirror, planar symmetry, and now I'll come back to your move or copy command. So now I want to move this on each of these nodes. You can try this like this by hitting on this base point here and putting it downwards here. This is method 1, or you can just define, since I've already created this earlier on. If you want to move in X is 0, I want to move in Y, which is 5, then I want to move in the last coordinate, which is 0, then I want to copy in, let's say 5 places, then everything will move at once. I just click on apply, execute, and now there it is. This it is. I'll click on close. But what I don't want is, I don't want this middle guy, so I should have just erased the middle guy from the last pre-created one before doing that. So I hit on delete. So now this is it, but our nodes are created for the previously defined bar, so I have to delete all these nodes away, because, and you can drag this guy here to your screen to keep it here instead of looking for it all the time. So what I will do now is I'll just hit on escape twice on my keyboard to be sure anything is not selected. I'll come down to this node selection, I'll hit on it once, I'll tick on all, then I'll tick on close, I'll hit on delete on my keyboard, and no delete only the selected by, I'll hit on apply. So as you can see, the numbers have vanished off from the screen. Then I'll tick off my node number out. To check, each bar has a number. Look at 4, 5, 10, 9. So to check this bar number out is by just clicking on this bar number. So for it to, if I want to select this bar, for example, I can just come back here and just type 20, and I have the bar highlighted. So 20, that is it there. So okay, so now what we are going to create now is the struct and the pollings and other stuffs. So I'll go back here and I'll choose a SHS bar. Just come here, then you come back here to choose, you click on that SHS. Then I want SHS of, let's say, okay, let me see, SHS of 120 by 120 by 6. So now I'll give it a color, any color I feel like. Okay, let me go for, I love green. I'll click on add, I'll click on close, then I'll move from this guy wells here downwards. That is it. Then I'll also move from here downwards here. This is another SHS. I'll also move downwards. And if you should notice, I created all these ASICs earlier on predefined. What I'll do now is I'll just come downwards here a little bit. To snap, I want to snap it to the center point of the bin, so which is here. So that is how to go about it. You can actually snap from bar to bar, okay, which I think is good. Okay, it does want to snap more better. You have to be careful and check you are doing the right thing. So now I want to snap the second point here at the intersection of this bar. Okay, so I'll do for this again. Do for this again. Okay, I'll hit on Ctrl Z. That is wrong. That is wrong. What I can do is, instead of doing that, I can just click on this toolbar 3940. I'll hit on Alt EE M, and I'll just pick this point. And I'll hit on Alt EE V, and I want to mirror about, is it XZ? Yes. XYZ and so I want to mirror this bar backwards to this guy. So you can tick here for your mirror, which is on the edit tab. If you don't have it on your own, just click on edit and choose it here, the vertical mirror. Or you can bring it out by pressing Alt EEM. No, sorry, Alt EEV. Alt EEV. So I want to move on YZ, which is Y and Z, and you just pick on your Z point here. Oh, sorry, no active selection. So I'll pick the bar again and try. I come here and I'll choose this point here. This is one method of doing it, or I can press Ctrl Z and show you another method. I'll just close. I'll pick this toolbar. Pick this toolbar here. And if I move from here downwards, so I'll just come to copy. So I'll select here as my base point since these are of the same angle. Okay, no, sorry. Let me do the mirror, that camera. So controls, and there we go. Okay, this is it. So this is okay like this. Now I'll copy this bar backwards here. So how do I intend doing that is just by picking this bar and holding it downwards. Then I'll pick on copy, move a copy. So I'll go from this base point here downwards here, and I'll go from this guy here. 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 So I'll click on close. So now we have it. So I'll put some bracings. So the bracing on the roof, it all depends on you, but for the side here, it depends on what you have on your architectural drawing, so you have to be very careful. So if you have an entrance here and you are running an X brace here, you should know that people will have to pass through here. So now I want to create a bracing. I would like to use, you can use CHS, which is what we prefer using at times, but for this class I'll go for an equal angle. So let me go for equal angle. Let's say equal angle of, okay, let's say 100. Okay, let me choose 100 by 12. I'll give it a color, any color I feel like. Okay, let me go for this. I'll click on add, I'll click on close. Then I would like to put my equal angle here. You might decide to hold on your drag and you place it here and here, likewise here also. So I hit on escape. I'll go back again to pick my equal angle and still on drag, drop, 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 drop. Hit on escape. Then I'll go from here to here, from here to here. So you just hit on escape twice to leave the command. So okay, so let me brace this guy here. I will brace it to the 600 which I created earlier on. I'll hit on escape. I have a 600 as its line up. I'll hit on escape. I'll brace it at the center point also. Let's say this is the center point. Is it D and G? Okay. Move. Hit on it. Hit on escape once. Go downwards here and replace. Hit on escape once. Go here. Replace. Hit on escape once. You go down here. You place. Hit an escape once. So this is it. I think this is good like this. So what next is I hit on close. I don't want to start creating this often and often. Then I'll just select this member. I'll hold down control on my keyboard. I'll select this one also. I'll select this also. Then I'll go downwards here to my copy command. So I'll just go down from this point here. I want to drop it at the last point here instead of creating for this side. So I have it repeated. Since I don't have anywhere to drop it again, I hit an escape once or twice. I'll click on close. Then I want to move what I have here to this part one, to the center part, and to the last part. So one, your light, your light, your light, your light, your light. So you go back to your copy command. You can move, you can copy it by just pressing the distance, but for easy access you just move from this guy here downwards to this guy here, so to drop at the back. Then from this guy here, likewise I want to place it at the center. So that is it. Hit an escape and you have this beautiful structure. So now what we have left is creating our loads. We are going to create our load cases, which is the ultimate and the serviceability limit state. But for this kind of structure, just the wind will act mostly on it and nothing more than the wind, and just the self-weight of the structure itself, which is more crucial. So for the serviceability limit state, which is the function of the structure, which can function of the structure under maintenance or the appearance, and the serviceability limit state is still under the appearance, which can be reversible or not reversible if you have some damage to it. Why and then mostly what we look for is just this deflection, the vibration damage of the appearance. And for cantilever we use L over 180, while for beam we use the span over 360, while for other beam except columns we use span over 250. Okay, so now we'll create our load cases. First we hit here, we'll give it a self weight, dead load, add. So I'll add other self weights to this self weight here. Then I'll come to my life load, which is about 0.75. I'll add. Then I'll come to my wind, I'll add. Then I'll just hit on close first. So now I want to define properties for this truss, which are only has intention if they are crossed like this. You just select similar, you can pick on one, then you right click, select similar by cross section. So it will select all bar created with the same section, and I'll go back to my geometry, additional attribute, and I'll come to your advanced bar properties. Then I'll just take this potential and I'll just hit on apply, since I like similar before. So just hit on apply. So it's already acting as a truss to this as a bracing. Click on close. And for this again, which other one? Okay, I'll pick the truss again. I'll do what is known as select similar by cross section. I don't want it to be checked, so I'll just come down over here and just click on it now. I don't want any load to be transferred to this truss here. Okay, so then I'll pick destruct. I'll do what is known as select similar by cross section. So the truss are only from a lateral restraint on the rafter, which is good. So I don't want to transfer. These are my polings also. I don't want to transfer any load to it, so I'll just ignore, because I'll be bringing in cladding to this structure to distribute my load properly, which is my pulling, my sheetings, and other stuff, and insulation. Okay, so what do we do next is creating our cladding. So you come down here to this contour, you bring down your parameters, you click on your cladding face, you click on your geometry to have it. So you have this arrow popping up whereby you can turn off your section shape if you are not comfortable with it. So I have this structure simple like this. So I want to create cladding for each and every guy here. Okay, you have to take it to the last point. So this is it. So you can go on and start creating each cladding for this, but since I know I'm using the same length, I don't have to do that since they have the same length. See, okay, this is under cladding. Okay, so what I'll do now is I'll create a cladding for this one here. So you create the cladding from the apex here downwards here and backwards here onto the top. So now you just click on close, then you can pick on this cladding, you go back to your copy, then you can now move this cladding by 5 meters, let's say in 6 places. You execute. Okay, it's more than 6, so I'll delete. I'll likely delete this off. Delete. So this is my cladding. Why for the upper cladding also, I'll mirror this cladding backwards there first, which is Alt E M. No, Alt E V. Then in YZ, just pick the center point and have it like this. I'll click on close. I'll pick this cladding, I'll copy it, copy, then 0,5 in 6 places. I'll execute. Why am I doing this mistake? Is 5. Turn apply. So now we have this one here. want to bring this cladding here. Okay, I want to cover this guy here. I want to clad this particular guy at the back here. Then just go back and draw another cladding. Okay, click on your cladding. You can put off your bar number if it's making the screen looks rough. I want to make another cladding here at the back. Okay, so now you click on close. I would like to put another, I want to clad this structure at the side. Guys, if the structure is clad, it's just meant for me to distribute my load properly. Just hit on control. Okay, so I'll click here, I'll copy from this guy was here to the last part guy here. Okay, so this is good, and now what is left is for us to add our loadings. You can turn back your section shape. You can turn it back on, and this is it. So now you click on this and hit on select similar by cross section. Then you ignore, it has already been ignored before. So what do I do next is creating our support. I want to make it a pin support, pin. Then you turn it to front. Then you can select. You should remember I have a node on this guy here at 600, so you have to select carefully. Turn it off for us to see. Okay. Just select carefully. Okay, wait first. Before you add your support, let's be sure we are bringing out all nodes we are not using. You come down here. Then let's go to system. All close. Okay. We go back to front. Come to your support and you can just put your support. Okay. Right. So this is it here. This is our support. So you click on close. You can bring back your panel shape, panel interiors. So this panel, I want to analyze it as a one way. So you select similar by thickness. You just come here and put it on one way. Let me check. Where's my Docker system? Okay, let's give it to this X. Okay, and then Y. Okay, so now you can just hit off your panel description and other stuff, panel interior, panel description, local system, and okay. So now you come to our loads.